Hi there, welcome back to CC4, which is costs, production costs and revenue, and we're starting from page 30 where we've got some exercises which are to do with total variable costs, fixed costs, total costs, marginal costs, etc. So this is something that I would expect you to take a look at yourselves, and then there are some responses to the answers. So page 30, some questions for you to have a go at. The detail of the questions is actually in the booklets, and then obviously we can run through the answers, the responses. Okay, so let's take a look at multi-choice question 1, which is to do with a mobile phone company, and its total cost, and also a range of different outputs. Okay, so the question you've been asked is what can be deduced about costs over the usual range of outputs A to B. Now you'll see on the top of page 30 you've got a graph which shows a range of different costs, and the total cost curve is shown across the whole quantity of a range of mobile phones. Now, in this instance, what that is showing you is B, that marginal costs are 0. And if we take a look at the point on the graph of A through to B, there is no change. The total cost line is completely horizontal. So that's demonstrating that the cost of producing an extra item in this instance is 0. So marginal costs are 0. Hence the reason that the answer to this particular question is B. There's some reasons behind that. Why is that? Well, because total costs are constant during that period of time when quantity is increasing. There is basically no additional cost, so there's 0 marginal cost for producing more units. That's as it's shown on the graph. In terms of why it's not C or D, well, in this instance, average costs are actually falling, because essentially with marginal cost being 0, between A and B, we're dividing the same total cost by an increasingly large number of items that we're actually producing. So that's the reason for that. Okay, so that's multi-choice question 1 on the mobile phone company. Let's take a look at question 2 then, where you've been given some information on a table, and in this instance what you're having to do is to demonstrate that you understand where the costs come from, okay, and how you calculate total variable cost, total fixed cost, etc., etc. Okay, now in this instance, to do this question, you might need to look back at your booklets to see exactly how you calculate different forms of cost. So for instance, marginal cost is a change in total cost divided by the change in quantity, and so as a result of that you might need to flick back and look at that as you're going through this process. You'll be given a certain amount of information in the table about how total output changes as number of units of labour change with a fixed quantity of capital. So in this instance, your cost of capital capital employed are £200, and then the firm can employ any number of workers at a constant rate of labour, which is £50 per unit. Okay, so in this instance then, total variable cost at 0 units of output and 0 units of labour is 0. But then we've got a total variable cost in this instance of adding an extra unit of labour, so that's £50. And we add another one, that's essentially £100. Total variable cost for 3 units of labour is going to be 150, and total variable cost for 4 is going to be 200. Then we've got to consider our total fixed costs. Well, we know that our total fixed costs are going to be £200, because the total cost of capital, which is a fixed quantity of capital, is £200. So at whatever unit of output, basically we've got £200 as the total. Then when we've got to calculate total cost, we're going to add total variable cost and total fixed cost together. So that's going to be 200, 250, 300, 350 and 400. And then we've got to calculate the average variable cost. So in that instance, what we're doing is taking the total variable cost and dividing it by the amount of output. Now, obviously in the first instance where we've got no output, and then we've got no average variable cost, For the second level, where essentially we've got our total variable cost at 50 with a total number of units of output at 20, so that brings that to £2.50. £2.22 for the 45 units divided into the total variable cost, and then 150 divided by 60 to get £2.50, and then finally 200 divided by 70 to get £2.86 as our average variable cost. In terms of our average fixed cost, again, because we've got no output, no units of labour, our average fixed cost is going to be 0. For in the first instance, it's going to be £10, where essentially our total fixed cost is 200 divided by, in this case, the total output of 20 gives 10. £4.44 for the 45 units of output divided into 200. And then £3.33, where we're taking 660 and dividing it into 200, and finally £2.86 for the 4 units of labour. Okay, if we then take a look at our average total cost, then we calculate that by taking the total cost and dividing that by the number of units produced. So our total cost is £2.50, and we're going to divide that by, in this case, 20 to give £12.50, and then £6.66 for the average total cost of, in that instance, is the total cost is 300 divided, in this case, by 45 units of output, and then we got, in this instance, our average total cost is going to be 350 divided by 60, and then finally 400 divided by 70, giving £5.72. Now remember, to calculate the marginal cost, we've got to look at the total change in cost, in total cost, and divide that by the change in quantity. So in this instance, again, for the first, where we've got no units of output and no units of labour, then essentially that's going to be 0. Now in this instance, then, where we've got a change in total cost, so in this instance we're taking a change of from 200 to 250, and then we've got a change in quantity, in this instance, of 20. So we're going to divide the difference 50 by 20 to get the £2.50. In the second instance, where we've again got an increase in total cost of 50, but in this instance we have got an increase in quantity of 25, then we're clearly going to take that and divide the one figure by the other. Then in the third instance, where we've basically got a change in total cost of another 50, so we're adding another 50, and in this instance we're then dividing that by the change in quantity, so we've changed it by the quantity by 15, hence we end up with £3.33. And finally, last but not least, where we've got an increase in total cost of 50 but a change in quantity of 10, then essentially that's going to give us £5. So you can see that gives a slightly different picture dependent on the figures that we're looking at. So in this instance, obviously the marginal cost initially is relatively high, goes down and then starts to climb. So obviously the cost of producing an extra unit in this instance is essentially going up, and then that obviously starts to demonstrate that we've got issues in terms of the level of the economies of scale that we're achieving. Okay, let's take a look at the third question then. So in this instance, you've got some information about spending by firms on internet security and how that's expected to soar over the next few years as results of recent outbreaks in computer viruses such as MyDoom. So this expenditure can best be classified as one of 5 options: a rise in variable cost, a rise in fixed cost, a reduction in revenue, a fall in marginal cost, or a rise in normal profits. Well, in this instance, we're basically, because we know that spending on internet security is a fixed cost, well, essentially that's why in this instance, question number 3 would be a rise in fixed cost as the answer, which is answer B. In essence, to explain that, the spending on internet security is basically going to be something that an organisation would have to pay regardless of how many units it's going to produce, and hence, as a result, that's going to be a fixed cost. Let's take a look at multi-choice question 4 then, where basically you've got a diagram showing the total cost function for a company producing DVDs, and it's asking you at a certain unit of output, in this case 5,000 units, what are the average variable costs? So you've got an option of 45,000, 25,000, £9, £5 or £4. And remember, in this instance, if we're talking about average variable cost, we need to take the total variable cost and then divide that by the number of units. Okay, so in this instance, clearly that's what we would need to calculate. Okay, now in this case, the answer would be D, which is £5, and the reason for that is that, in essence, what we've got is total costs being shown on page 31 of your booklet of, in this case, £45,000. Okay, but you can see that the total cost, or the total cost line, starts at £20,000. So in this instance, what that is telling us is that essentially we must have fixed costs of £20,000. So in order to then calculate the difference between those two things, we've got to look then at the total cost of 45,000, take away the fixed cost of 20,000, and then in this instance divide that by 5,000 units to give, in this case, the answer of £5. Okay, so that's the reason for that multi-choice question 4 being the response being D. Okay, so that's a few example questions to sort of test your understanding as far as some of the previous work that we've done. But now we're just going to bring that all together and look at the way in which the different items that we've talked about, from average fixed cost and average variable cost, how these different curves actually come together. So fundamentally, we're going to show that in graphical format. But if we take a look, and let's just draw them in, and then we'll explain exactly what we're talking about. So basically, we've got two sets of axes. We've got cost quoted against output. We've got the marginal cost curve, and then the average total cost curve included there. Okay, now effectively we're always going to have a U-shaped average total cost curve, because to some degree, we remember, if we're talking about average total cost, we're thinking about average fixed cost, average variable cost, and also there is clearly going to be a link to the change in marginal cost too. So there will always be some sort of relationship between those things. Okay, if we actually take a look at the next one, I'm going to just move myself out of the way for a moment to make it slightly easier for you to see. In this instance, what we're talking about is a change, or we're just going to draw in initially average fixed cost. Now, effectively, remember, fixed costs are those that don't change with output, and initially what we will try to do is to obviously bring the average fixed cost down as much as we can, to the point where effectively, as we produce more output, then the average fixed cost is hopefully going to fall, because it's a fixed cost, and as we produce more output, then clearly average fixed cost will fall. If we draw in our marginal cost curve again, and then also draw in our average variable cost, you can see clearly in this instance, to calculate our total cost, our average total cost, we're going to need to take average fixed cost and average variable cost and add those two things together. So you're always going to find that the average total cost is going to be related in some way to, there's clearly a relationship between both average total cost and average variable cost and average fixed cost, but also there is a link between marginal cost too. Now, in this instance, what we're saying is that adding average fixed and to average variable cost is going to allow us to obtain an average total cost curve. Okay, but also you should see that in this situation, the marginal cost curve, and so this marginal cost curve here is always going to be crossing the average variable cost and the average total cost at the lowest point on those curves. So effectively what we're saying is that as soon as our average our marginal cost starts to get over and above the variable cost or the average total cost, that's the point at which obviously that's going to then influence the overall extra cost. So average variable cost will start to go up if marginal cost is increasing. The amount of marginal cost per unit per and extra unit of item produced is more than the variable cost, then that clearly is going to then cause the average variable cost to increase, and the same with average total cost. Okay, so that hopefully brings that sort of summary together and hopefully explains a wee bit more about the reasons why you get this interrelationship with the different curves, different short run cost curves. So let's just summarize that, and then we'll move on and start looking at economies and diseconomies of scale. So things to bear in mind then, in the short run, cost curves are derived from short run production theory. Remember, when we talked about short run, we're saying that effectively we've got some costs that are fixed and some that are variable. Now, in the long run cost curves are going to be derived from long run production theory. And one of the issues around the long run in economics is that actually we assume that all costs are variable, because even the fixed costs that aren't going to vary with output, we could choose in the longer run to expand the capacity of a factory or get a larger factory or whatever else. And then clearly that would mean that what would normally be the fixed costs would also become variable too. In terms of short run costs, as we've said, they're made up of both fixed costs and variable cost. But in essence, fixed costs in this situation are the costs of that a firm might incur when it's paying or hiring certain fixed factors for certain fixed factors of production. Variable cost change as the level of outputs change, and total costs comprise all of the costs that are incurred when producing a particular size of output. Okay, so this is essentially just breaking down different types of cost. When we start to look at average cost, then we take the total cost that we've incurred and divide that by the size of the output that the firm is producing to give us average costs. And finally, the marginal cost is the addition to total cost resulting from producing this one additional unit of output. Remember, we talked about things that happen at the margin and how important that is in terms of economics, in order to appreciate how a change at the margin might actually cause things to be somewhat different. And then finally, average total cost and average variable cost curves are always U-shaped, with the marginal cost curve cutting them both at their lowest points. Okay, so we'll talk a little bit more about the reasons why we've got this U-shaped shape going on for both average total and average variable costs as we move to look at economies and diseconomies of scale. Okay, so in terms of this principle of long run and in terms of what the long run is in certain different types of industry, clearly an oil refining industry is going to be massively capital intensive, and it's going to take a long time to step up production and make changes to new oil rigs and refineries, for instance. So clearly an industry like oil refining, you're going to have long run costs, and they are going to be significant. Whereas a painter and decorator, clearly you're going to have a situation where it's heavily labour intensive, you've got minimal capital equipment required, just ladders and brushes, and it's clearly quick to acquire. So clearly the long run cost of any business is going to be significantly different depending on the industry. And remember, in this instance, what we're saying is that in the long run, that's the period of time over which a firm will be able to vary the inputs of all its factors of production. And as a result of that, clearly, that then means that in the long run, all factors of production are variable in terms of their cost. And the only thing to bear in mind is that the state of technology is one that is less difficult to change in that it's only going to be variable in the very long run, as opposed to it being a fixed cost in most instances. Okay, so let's take a look at the next section then. So if we move on to look at page 32 in your booklets, there is some content on this principle of economies and diseconomies of scale. And some of the things you're going to need to know include the following. So the difference between internal and external economies of scale, and this is something we'll look at in a minute in the booklet that we're working through. The reasons why we get diseconomies of scale, the relationship between returns to scale and economies or diseconomies of scale, again, is something that we'll look at, both give explanations for and also show graphically. The relationship between economies of scale, diseconomies of scale, and the shape of the long-run average cost curve is also going to be something that you'll need to understand and be able to explain. And then the L-shaped long-run average cost curve is also something that we'll need to identify the reasons for. The other thing that we'll also need to consider is a concept known as the minimum efficient scale of production. And again, we can show that, we can explain that and define it, but also show it graphically, and that's something that we'll do shortly. And you as students should need to be able to categorise and give examples of both internal and external economies of scale, and also to understand the significance of this principle of the minimum efficient scale for the structure of an industry, and also the barriers to entry that might create for businesses that may be thinking about moving into that particular industry. So let's take a look at economies of scale in a little bit more detail then. In essence, what we're talking about here is in order to achieve economies of scale, and again, I'm just going to move my Visog over there a bit to make it slightly more straightforward for you. It's basically a fall in the long run average cost of production as output rises. Okay, so effectively what any business is trying to do is get to the point where it can achieve the best economies of scale, and that fundamentally is reducing its long run average costs of production as output starts to rise. So in this instance then, we can have a number of different alternatives. We can have something known as constant returns to scale, and on page 32 in your booklet, you've got a box of definitions which talk about constant returns to scale, minimum efficient scale, MES of production, and also diseconomies of scale. So these are all areas that you need to understand. Okay, if we talk about constant returns to scale, that's basically when a firm experiences constant long-run average costs. So basically, the average costs don't change as it expands output. So in that instance, you've got constant returns to scale. Now, the minimum efficient scale of production is something that, again, is an important principle. And fundamentally, that's the point at which the lowest level of output at which long-run average cost is minimized. And again, we'll show that on a graph in a minute, which hopefully will make a little bit more sense for you. When we get to diseconomies of scale, that's the point at which we get a rise in the long-run average cost of production as output rises. And that can be caused by a number of different things, which we'll look at as we progress through this set of slides. So when we're talking about economies and diseconomies of scale then, if we want to show this graphically, there's a number of ways in which we can do that. And again, we'll just draw this in and then build the example and then explain it in a wee bit more detail. So in this instance, we've got a situation where we've got costs against output. And in this instance, what we're doing is drawing in long run average cost curve. Okay, you can see this is a U-shaped curve. like so. Okay, now in this instance, if we then add some more points at which we can actually explain this in a bit more detail, we've got a situation here where effectively we are, by increasing the level of output, we are starting to achieve economies of scale, okay, or we're increasing our returns to scale, where our long run average cost has moved from this point here downwards to a point where we're starting to achieve economies of scale by, and again we'll look at both internal and external ways in which we can reduce the overall costs of our business and the long run average cost. Now, at this point here, where effectively our sort of graph has bottomed out and it's become constant, we've got something which is known as constant returns to scale. Okay, so during this period of time, or during the amount of output here, then we basically have got the same levels of return to scale. So we're not adding extra long run average cost. We're basically at the point where we're achieving, anywhere in this area, we're getting what's known as constant returns to scale. Okay, if we then move over a little bit further to the point where long run average cost starts to increase, we're starting to get what's known as diseconomies of scale, or decreasing returns to scale, and that's where our long run average cost starts to increase. And again, that can be for a whole number of reasons. Now, this is quite an important graph to get your head around, the fact that we've got this principle of at some stage, when we've got a relatively low level of output, we're going to have some high costs, some high fixed costs, some high variable costs possibly. But what we're trying to do is work through to the point where we can actually reduce that by benefiting from economies of scale to the point at which we can get to the lowest long run average cost. And obviously, once we get to that point, clearly that's somewhere where we'd like to stay. But at some stage, we might also go past that to the point where we're starting to become less efficient, and we're going to then start to suffer from something known as diseconomies of scale. Now, the other thing I just want to draw your attention to, and as you saw that pop up on the screen, is this minimum efficient scale that we mentioned in terms of MES, and that this is the minimum quantity for which you can achieve minimum long run average cost. And you can see at this point here, clearly we've got to the point where our long run average cost curve has got to the point where it's actually horizontal, and this is the minimum quantity. In this case, it isn't given as a quantity, but the minimum quantity that we can achieve our minimum efficient scale, where we've got the minimum long run average cost, is shown here by the point at which our U shape has stopped, and we've got this the start of this horizontal line where we're starting to get constant returns to scale. Now, clearly, this range here, where we've got this low range or a long range average cost at its minimum, is the optimal output range. So if we can stay within this area here, that's the point in which we're producing output at the lowest long run average cost. Okay. However, when we get past that point, then obviously that starts to make it more expensive again. Okay, so that's quite an important graph to understand and to grasp, and also to demonstrate the points at which you get these changes going on as far as economies and diseconomies of scale. Okay, so let's take a look at the sources of economies of scale then, and fundamentally it's about how do we reduce the cost of production, the long run average cost of production, by benefiting from certain economies of scale. So in some cases and again we're just going to move me over so we can actually run through this simply and hopefully relatively easily. So we might be able to benefit from technical economies of scale. So we might be able to, once we get to a certain size of business, we might be able to use that to be able to say, in this instance, we could choose to maybe use better technology, better computers, etc. And as a result of that, we might be able to improve the efficiency of our production and maybe reduce our costs of production too. So there are a number of different types of technical economies of scale that we can include. And if we look on page 33 in your booklet, there's a whole bunch of internal technological economies of scale, which include things like improving your mass production by using assembly lines, maybe using some specialization in your workforce so that effectively we start to lead starts to lead to more cost savings. Okay, there is this principle on page 34, which again will take a little bit of reading through and understanding. Is this principle of the container principle, which is to do with as you expand in terms of the size of a particular container in this instance, then you can gain significant savings based on the overall scale of the size of the container. Okay, so that's on page 34, and it's something that you can have a read of, and hopefully it'll make some sense. And we also will explain that in a bit more detail when we come to some calculations. Now, so we've talked about internal changes or internal economies of scale and technological or technical economies of scale, but we can also get marketing economies of scale. So large firms might be able to afford bigger advertising campaigns and might be able to get specialist staff in marketing fields that maybe smaller firms wouldn't be able to afford. You're also going to be able to gain purchasing economies of scale if you are bulk buying and you're buying more quantities and more units of quantity than another company. You might be able to negotiate a better deal for yourself based on purchasing bulk buying and also negotiating cheaper cost per unit. We can also get managerial economies of scale. So again, we might be able to employ specialist managers in, say, the IT area, or in terms of specialist managers in terms of production engineering, or a number of different ways in which we can gain managerial economies of scale. We might also be able to gain some financial economies of scale. Again, these are all listed on page 35 in your booklet. So large firms are considered to be more creditworthy, and as a result of that, they might be able to negotiate with banks lower rates of interest on loans, etc. And obviously, that's a means by which you can reduce your overall costs and reduce your long run average cost too. In some cases, you've also got risk-bearing situations, so large firms are more likely to be able to take bigger risks and maybe benefit from diversifying, for instance, moving into markets that maybe others might not be able to, and obviously you can gain some serious benefits from that if you're first into a particular market. Okay, if we take a look at some external examples then. Okay, and in this instance, we'll just list a few. So maybe that we could gain some economies of scale by better transport networks that are provided to you if you're a larger organisation. You might find that the government or certain areas might be developing their infrastructure to help that whole process. Lower training costs might also be achievable, but based on the fact that you can negotiate with training providers and get lower costs of training as a result. Research and development facilities also might actually follow larger organisations, and obviously that means that you've got more options to do research and develop new products and services. You might also find that component suppliers come to the area because if they know that you're a large organisation and are likely to place work with them, they might choose to locate themselves closer to where you're based. You might also get some technology. Again, you tend to find you get technology hubs in different parts of the country where there's a high level of economic development going on. So that again could be another way of considering that. Okay, so those are the sources of different forms of economies of scale. Now, I mentioned this principle of the container principle, and there is an example and a question for you to consider, which is something that we're going to go through probably next time. I think we might stop there. Give yourself a chance to consider some of the things that we've just been talking about, and then obviously we can move on and take a look at the next set of content, which is where we're going to move on, look at a couple of exercises, and also look at some external economies of scale, as we've mentioned, as we talked about, but also then look to see how each one of those might cause changes to the long run average cost curve. Okay, so thanks very much for listening once more, and we'll be back chatting together soon. Thanks very much.